So hi everyone, welcome to the Network MIDI 2.0 presentation and panel. On the panel today, we have 4 members of the Transport Working Group of the MIDI Association. Me, that's Florian Baumers. I am a member of the TSB at the MIDI Association and also the chair of the Network and Transport Working Group. I run my own software company, which also makes a hardware called the Bonebox, and I specialize in MIDI translation and MIDI networking. Next up, Benoit.
Hello, I'm Benoit from Keysbox. I am one of the founder of Keysbox company. We are specialized in MIDI interfaces based on internet communication.
Thank you. Phil.
And hello, I'm Phil Burke. I work at Google in the Android Audio and MIDI group. We're responsible for the MIDI APIs. And I've been working on MIDI 2.0 and the network transport.
Cool. Mike?
And I'm Mike Kent. I am chair of the MIDI 2 working group in the MIDI Association and co-founder of Ominote. And Ominote is a company that has been involved with the MIDI Association. We make the Protozoa, which is the testing platform for MIDI 2.0 compliance and for prototyping. And we will be shipping as soon as the spec is finished. We'll be shipping network interface devices for MIDI 1.0 and MIDI 2.0.
Very nice. So today on the agenda, we'll first start with a section about the business case for Network MIDI 2.0. Then we'll see some of the technical details of the specification. It is still in progress, so any part of that may change, but we'll share what we have. Then we'll have a section where every member of the panel shares some of his own experience. And at the end, we'll have time for discussion and Q&A. All right. Mike, you're next with the business case of Network MIDI 2.0.
Thanks, Florian. So why networking for MIDI 2.0? Well, we've had RTP MIDI for years, but it only supports MIDI 1.0. With the introduction of MIDI 2.0 now, we need a new network specification to handle both MIDI 1.0 and 2.0. Network technology has become affordable. There are a lot of resources for developers and device design. And then for users, every device in your home is connected by a network. Home networking is reliable, and people are generally comfortable with it. And so it's time for the MIDI industry to embrace more networking, and so this is what we're working towards. What we propose uses the Universal MIDI Packet for MIDI 2.0, which supports both MIDI 1.0 protocol and the MIDI 2 protocol. Now, of course, the original 5-pin DIN MIDI 1.0 connection from 1983 is still widely supported, and there are other connections available for MIDI, Bluetooth, and so on. But today, the most common carrier for MIDI data is probably USB. Most MIDI data sent today is generally over USB cable. And so we are going to add to this collection of interfaces things for MIDI 2.0. So in 2020, actually, the spec for USB MIDI 2.0 was released. And this year, we'll be bringing out the network specification. It has some advantages. It's a little bit different from USB. USB is still great for connecting to a computer, but there are some advantages for networking that make it also something we should be adding. The first one is just a device-to-device connections between various MIDI products without everything going through a central host computer. And so that's possible via network. We can go long distance. Ethernet provides long distance, 100 meters for a link with ground isolation. Just like the original 5-pin DIN MIDI has isolation so you don't have ground loops. The same thing exists on Ethernet. There is an advantage possibly in performance. Our initial testing of the network spec we've been working on shows that it probably has a notably lower latency than USB MIDI. We can send power over Ethernet as well, so we can, like USB, we can send power to a device over the network connection. And this same specification that we're working on works not only over standard Ethernet networks, but can be adapted onto Wi-Fi networking as well. So giving us wireless advantages in the future, coming alongside Bluetooth MIDI, which is really convenient. So today, USB works really well. It's affordable and will continue to be popular for connecting your MIDI devices to a computer. And networking, we see, will come along as a companion to that, to give some different features for different kinds of applications. And we see that growing to become a common connection for MIDI 1.0 and 2.0 alongside the transports that we already have. Thanks. Back to you, Florian.
Yeah, thanks, Mike. That is very compelling. So let's have a look at the details of the Network MIDI 2.0 standard that we're working on. So the general goals that we try to achieve with that specification is basically send and receive UMP over the network, obviously. As Mike said, that has great properties like low latency, low jitter. And another aspect that we need to provide with the specification is that it's a reliable transport. We don't want to have packet loss. There are different ways to solve that, but we'll see a little later the options. Also, on a network, you can't just plug in a device and it talks to each other, because it's a network. There could be many devices plugged into the network. So we need connection management of some sort, discover other MIDI devices on the network, and see who else is out there by name. So when you want to connect to a device, you see the name and you can just select it and connect to it. No more cable plugging and unplugging only to get connection management. Obviously, there is the risk that unauthorized people or bots will try to connect. So we also need to make sure that there are ways to prevent harmful unauthorized access. Okay. So the first version of this specification is targeted to Ethernet and wireless LAN. So basically running UDP. We have considered TCP, but this first version will only run on UDP. The specification has 3 sections. The first section is discovery, what I just explained. Then there's the session protocol for connection management, basically. And last but not least is the actual data I/O for sending and receiving UMP packets over the network. So the first section is discovery. For that, we use an industry standard MDNS plus DNS-SD that's commonly known as Bonjour, as implemented by Apple, or also called ZeroConf. Typical, or most, or all operating systems currently in use, like Linux, Windows, Mac OS, have MDNS services built in. So you can just plug into that and advertise your MIDI 2.0 device on the network, and also discover other devices that are on the network and expose themselves via MDNS and DNS-SD. The information you can get via this discovery is the IP address and the UDP port for connecting, the endpoint name, which is the same endpoint name as also available in UMP, and the product instance ID, which is sort of could be a serial number or some other unique ID that lets you re-identify that device when it goes away and then comes back to the network. The entire discovery section is optional. So it is possible to build maybe a very small device that doesn't need to be discovered or doesn't need to actively discover other devices out there. So in that case, the device needs to be connected to directly by IP and UDP port. That is possible. Obviously, the user experience will not be as good as with automatic discovery. So the recommendation is, when you can, always use the discovery using MDNS and DNS-SD. All right. The session protocol is the second section of the specification. The general idea is that what we call a client starts a session with a remote host. The host has advertised itself usually via the discovery. So a client uses that IP address and port number to start a session. The session protocol is newly developed. It's roughly based on RTP MIDI session protocol, but we've simplified it, and we're using plain UDP messages with that, with a very small header. So it's also very efficient and can be extended in future if we like to. The session protocol defines commands, what we call commands. So all the session messages like setup, maintenance, and termination of a session, basically connection management. So if you want a keyboard to talk to a synthesizer, you would use the session protocol with a command to start the connection. And while the session is up, you would also need to sometimes do some maintenance, like verify that the session is still up, the other device is still available. And once the user wants to disconnect, terminate the session. Okay. And as initially said, it's on a network. There's always security to be considered. So we've built in different ways to authenticate session setup to possibly prevent malicious access. The simplest way is to just not implement any authentication. Maybe if you're in a closed network or something, then that's enough. When a client tries to connect to a host, the host will just accept the session, and then they can talk to each other. Then the second kind of authentication that is available is just with a simple authentication or confirmation by the user. So the client tries to connect, and then the host will pop up a window if it has a screen, or maybe blink a button or something that the user can confirm the session. And for more secure or more restrictive access, there's also a password-based authentication available, or even username plus password. Say you're in a classroom situation or in a music school, you can give out different username and password combinations for the students to log into different MIDI devices using Network MIDI 2.0. And the third section of the specification is to actually send UMP packets. That is only possible once the session is established. And then host and client can both send and receive UMP packets. Because we're using the same data format for session packets and for UMP data packets, they can be mixed and matched. So again, that should turn out to be very efficient. And you can also group multiple UMPs in one UDP packet. Again, that will provide low latency and best usage of the network. We have currently two mechanisms for data integrity, a simple one and a more advanced one, and implementations can use those as needed depending on the use case and the transport. Obviously, on Ethernet, it's quite reliable, so maybe you don't need much. You don't need to care much for data integrity and solve like missing packets, because that doesn't happen much on Ethernet. However, on Wi-Fi, that actually happens. So maybe you should implement the more advanced techniques for data integrity there. Currently, we are prototyping the current specification, actually for some time already. We have, last I counted, 9 MIDI Association member companies who have implemented prototypes. We have tested the different implementations and sometimes found a few things to fix either in the implementation or in the specification. But in general, it works fairly well, and we're confident that the specification as it is will work fine in implementations. And these slides are from the NAMM show. So we have shown some prototypes at the NAMM show in 2024, and people could see the Network MIDI 2.0 in action. The specification is rather mature. We have to do some editing work, but we hope to ratify it in 2024. Obviously, we cannot promise it. It's going to be voted on, but that's the plan. And then once it's a public standard, who can implement it? Every implementer can create their own implementation of the Network MIDI 2.0 protocol. But especially for MDNS and DNS-SD, you would usually use operating system provided services. And maybe even some operating systems will implement Network MIDI 2.0 directly into the OS, so an application doesn't even need to bother with this at all.
Okay, so Google is very interested in the network MIDI transport. We see one advantage in that the network transport can be built on top of the operating system, so it can port easily back to older versions of Android. I've been working on a prototype app written in Kotlin and Compose, and found I could access all of the operating system features that were needed to implement it. So this prototype app does some basic testing, some basic conformance tests, creates sessions, sends data, simulates data loss and packet recovery. It also includes some ping latency measurements and packet loss measurements. We plan to make this app available once the spec is released. It's available now to MMA members internally. One of the other things I've been experimenting with is prototyping a device proxy, which on the next slide you can see what we do. So we can go to the next slide here. Right, so what this does is it allows us to take existing apps or existing, MIDI 1.0 apps or MIDI 1.0 keyboards or MIDI 2.0 keyboards that don't have networking, plug them into an Android device or run the app on an Android device. And then the proxy will communicate to the existing app on one side, and it'll communicate to the network on the other side. And so what that does, it allows any existing application to become available on the MIDI network as if it was supporting the network transport itself. So this allows for Android apps to communicate with apps that are running on other operating systems or other devices. So it seems to all work. So, but thanks.
Yes, thank you, Phil. So this is the section where every member of this panel can share some of his own experiences. Next up is Benoit. Would you like to continue?
Yeah, I will basically continue on what Mike just said during his part of the presentation. There is a thing. Kissbox was one of the first company to implement the RTP MIDI protocol. So we have a huge knowledge about the use of MIDI over Ethernet. And basically, the nice thing with RTP MIDI was to prove that it was possible to use Ethernet to carry MIDI. But the problem with RTP MIDI was that basically nobody really managed the standard. And with UMP over Ethernet, there is a huge forward leap because basically I would say that many aspects of RTP MIDI were not clearly defined. And with UMP over Ethernet, it's not the case because we have discussed a lot. We checked the implementation a lot, and basically, what will happen with UMP over Ethernet is that this is something we know it works, and basically it's stable. So it's a big change compared to RTP MIDI. We know that MIDI over Ethernet is a reality, and UMP over Ethernet is really more professional compared to what was done with RTP MIDI at its time.
Thank you, Benoit. Mike, would you like to share some?
Sure. So at Omino, we've been developing, and one of the things we've been doing in the MIDI Association is sharing with each other. Florian mentioned there's 9 prototypes by various members of the working group, and a number of those are shared as open source among the members. And so we're running some of that networking on the Protozoa. I believe Benoit is one of the people who contributed to code on the Protozoa for this. So there's a cooperative thing going on in the MIDI Association that is fantastic. And we see this network specification actually operating now, excuse me, on these prototypes. And it seems to be, pretty stable and working really well, even before we get it out in the marketplace. These early prototypes have kind of proven that it's all working well. And so we feel very confident moving ahead with a line of products that are going to implement this. And we think that this will be really great for MIDI users. I'm a MIDI user myself, and we see it kind of in commercial installations, large facilities where you need to send signals long distance. There's probably already a network in that building. And so you can send MIDI data alongside your audio data, maybe AES-67 audio or Dante, whatever. This will just run alongside on that same network. And so we see great applications in commercial installation where you need to send some data. And then in the home studio, I can imagine sending, every device in my studio, one Ethernet cable. Ethernet cables are cheap. One Ethernet cable, send it. And on that cable, we've got audio, MIDI, and power. I'm a dreamer. I'd love to see that happen so that all the devices are connected that way. And it reduces cable clutter. And we have yet to really dive in deep to Wi-Fi and how well that's going to work. But I think that that's something people on this panel and other members of the MIDI Association will be prototyping in the near future as well. And I think we'll see good results on home Wi-Fi networks as well. And so I think this shows a lot of promise. I think people are going to really like the way this network spec makes MIDI 1 and MIDI 2.0 accessible and connectable.
Thanks, Mike. Yes, and for my own company, I have implemented this network spec for the Bonebox as a prototype firmware. It was an interesting experience for me because I first created the specification in the working group, and then implementing it was just as I hoped it would be, relatively straightforward and no unexpected problems coming up. So the simplicity of the specification also meant quite some simplicity for the implementation. And that, I hope, will mean that we will see actual implementation soon in the marketplace and operating systems, maybe also in software and in devices in general. And I'm also I have a network MIDI software called Bohm Network, and it was also very easy to add the UMP over network protocol, the Network MIDI 2.0 protocol, to that application. And it's just so nice to see when you have all these devices connected on the Ethernet in the home studio, and you see every device by name. You just click on it and you connect to it. No more trying to type in IP addresses, finding out all that, for example, with RTP MIDI, or I mean, it's just a very good user experience. And well, for me, it's a dream come true once we have that specification in the marketplace.
If I can
Okay.
add something, Florian.
Yes, please, Benoit.
There is one thing that we forgot to say, which is very important. The first thing is that when I was speaking about RTP MIDI, is that and bouncing on what you just said, basically when I implemented UMP in the Keysbox product, I found that it was easier to implement than RTP. So UMP over Ethernet is easier to implement. It works faster, and what we forgot to say is that it works on microcontrollers. It doesn't really need a powerful computer to run. It runs on small microcontrollers. So it can be used on cheap products also.
Yes, that is very important. Thanks, Benoit. We are at the end of the panel discussion, basically, but maybe there are questions from our guests. Then we would be happy to answer. And you will probably need to unmute if you want to speak up, or write in the chat. So there's a question about remote management. So the idea here is that you have multiple devices in a network of MIDI devices, and from, say, a computer, you can access, okay, you can see all devices, and then say, okay, keyboard A is talking or is now connecting to synthesizer B from the computer. So you remotely control the connections between other devices. And that is something we are working on. We may not be able to, or currently it's not planned to put it into the first version of the specification, but we put in all the provisions that we can add it as an add-on in the next version of the specification. And hopefully that will also become a reality. Okay, here's a question. Okay, it's not a question, it's a statement. So it says it seems very promising and is something he'll likely want to implement in future products. Yes, so that sounds great. And the same is true for me, and I think for everyone on this panel. Anybody wants to speak up from the attendees?
Okay, I think that's a wrap.
Yeah, if you're a developer and you're not a MIDI Association member, please join the MIDI Association and sign up to participate in these kinds of this kind of work that we're doing. We would like more developers. There are developer resources as well. You know, we have a weekly developer support meeting where developers can come and ask questions about MIDI 2.0. There are resources online. We have a lot of articles. We just published several articles, I think 4 articles on implementing USB MIDI 2.0 on MIDI.org. There are open source resources online, including at MIDI2.dev. engage with us. If you're not already a part of this discussion, reach out to us through the MIDI Association, and we'd love to talk to you and get you involved in this work that we're doing.
Yes, Mike, I fully agree. And that concludes our Network MIDI 2.0 panel. Thanks everyone for watching, for attending, and especially you, all the panelists. Thank you for sharing your experience and answering questions. So, goodbye, everyone.
Thank you. Thank you, Florian. Bye.
Goodbye.
Bye, everyone.